Hello, in this video we're going to revisit the example of finding the volume obtained when the curve f of x equals x squared is revolved around a particular axis. And in the example 1 video we did the volume of revolution obtained when revolving around the x-axis. And in this video we're going to do the volume obtained by revolving around the y-axis. From, let's say, y equals 0 to 4. So the first thing I would suggest is always to plot the curve. And when we plot the curve, notice that I'm plotting with respect to x. And the reason why we're doing x equals 0 to 2 is because when x equals 2, that gives us y equals 4. And that's exactly what we wanted here in the example. So let's go over here and draw the curve and label the axis around which we're revolving. So we're revolving around the y-axis. I'm going to draw my little curvy arrow here to signify that I'm rotating around the y-axis. Having done that, we will find the mirror image of the function over the axis. And there's, well, a bit squiggly, but you get the idea. And now we want to connect the two curves here. And so the volume, the 3D shape that we're going to end up with is like a bowl. It's like a serving bowl or a fruit bowl or a basket. So that's the shape we're going to end up with. And we can go back over here to Maple and make Maple do a drawing for us. So just to compare, in the previous example, we were revolving around the x-axis and we ended up with something that looks like a trumpet. And now we're going to go around the y-axis. So let's do that here. We'll do x squared. And let's go over here to vertical, the distance of the rotation line from the coordinate axis. And notice here that we end up with a bowl or a basket sort of shape. Okay? And notice that we have the y-axis going from 0 to 4 and x goes from 0 to 2. So we can display that if we want. Which is very nice. Now, let's consider how we would compute the volume. So to do that, let's go back over here. I'm going to use the method of disks again. And to do that, we need to make our disks, the height of our disks here, goes parallel to the axis we're rotating around. So here's a representative disk. There's the lower edge. And here's another little height. And there's the front edge of my disc. And then it's going to swing around behind. So there's my disc. And here's the center of the disc. So I'm going to exaggerate that over here. Here's my disc. Thinking about this in terms of the volume of a cylinder, you can think about it that way and use the volume of a cylinder that we know and love from geometry. So thinking about that, we have a radius here. And in terms of this problem, here's our radius. The radius is exactly this curve. That's the red line here. That's the radius from the axis of revolution out to the red curve. That is going to be our function in terms of y. So we have to think about what is this red curve as a function of y. And that is going to be the square root of y. So that's our radius, and that's this edge here of the curve. And then when we think about the height here, so the height of our cylinder, if we think about the height of this is the change in y. It's how much we've changed in terms of y. So it's going to be dy. Now, this is not the only way to compute the volume. You could go by shells. That's another method for doing this problem. But we will use the method of discs just to get some more practice with that. So we'll start off recalling volume equals pi r squared times the height. So pi will remain pi. And now the radius, we said that the radius is the square root of y. And we have to square that because radius squared is part of our cylinder volume formula. And now the height we said is going to be dy. Now we'll have to sum up the volume of all those little discs. So that means we need an integral. And we're going from 0 to 4. So these are all going to be y variables. And I'm just going to copy over what we have here. Okay, so this is y equals 0 to y equals 4, pi, the square root of y all squared, dy. And when we work that out, what we're going to get here, we'll still have our pi. Let's get rid of that. And the square root of y squared, since y is positive, it's just going to be y. You have to be a little bit careful if y was negative or something like that. But in this problem, it's just going to be pi y. And we keep working this out. The antiderivative, well, we're going to have pi over 2 y squared. And we're going to evaluate that as y goes from 0 to 4. And let's actually do that so that we can compare with what we'll get from Maple's answer. So let's see, we'll have pi over 2 out in front. And now we're going to have y squared, so that's going to be 4 squared minus 0 squared. So that doesn't contribute much at all. And we're going to end up with 16 pi over 2, or 8 pi. So if we go back to what Maple wanted to give us in here, just to compare, notice that Maple is using a different technique. Maple is using shells, but the answer is the same. We're both getting 8 pi. 2 ways to get the same answer, but do notice that we have the correct shape, we have the correct picture, we have the correct 3D drawing, and that's fine. Also notice that the volume that we obtained here was 8 pi for our basket shape. And notice if you go back to example 1, that is very different than the volume we obtained when we went around the x-axis, which was this trumpet or witch's hat type shape.